Okay, so before you start analyzing your data statistically, you need to have entered it, and so it makes sense to enter it in a format that the stats program can use. So that's what I'm going to talk to you about in this video. So just an example of the type of experiment you might do, you might be studying the effect of some treatment on some bugs. So you would have two groups of bugs, one where you gave them the treatment, maybe that's a pesticide, maybe that's a nutritional supplement, and then you would of course also have a control group where you didn't treat them with whatever the special thing was that you were treating them in the treatment group. And so you'd want to see what that did to the bugs, and so you would measure some various things. And so you might measure the length and weight of the bugs. And these things are known as continuous variables because, say, in terms of the length of the bug, a bug could be very long or it could be very short or anything in between. So length in this case is a continuous variable because it can be big or small or anything in between. There's a continuum of lengths that you could have, and so that's why it's a continuous variable. In contrast, you might also measure something like outcome, like whether they lived or whether they died. And the way I've just described that, that's an all or nothing thing, right? Either they're alive or they're dead. They're not anything in between that. Now, you might consider some other variables that you could measure, like their health, where they could be really sick or they could be really healthy. And in that case, those might be continuous variables. But in this case, the way I've described it and the way we're going to think about it, it's just an all or nothing outcome. Either they're good or they're bad. So these are known as categorical variables because they fall into categories. Sometimes they're also called discrete variables. So I'm now going to look at how that data might be entered, and I'm going to start by showing you how your data, well, should be entered. So here I have it entered in Excel, which is something that many of you will use to enter your data. And what you can see is that here every row is an observation. So in the case of our experiment, every row would correspond to one bug that we measure. Okay, so each row in my spreadsheet here is one experimental unit. In the case of the experiment I described, it's a bug. And one of the things you'll notice for how I've entered the data is that every row has all of the information, right? So I've written control a bunch of times and experiment a bunch of times for every bug. Now that's in contrast to some other things you might do. You might just say, well, I'm just going to write control once and then enter all of the control values, and then I'm going to enter experimental once and enter all of the experimental values. This is not a good way to do it. Okay, the stats program will not understand that all of these values are also control values. Sometimes students will, add a row of space to just, help organize their data and make things a bit more clear. But again, this is not going to help you. Your stats program is not going to be able to see that the controls apply to all of these variables. Okay, so you really need to have all variables or data provided for every one of your observations. Now, another common mistake that that people do when they enter data, and it's a reasonable thing to do, except that the stats programs don't like it, is that they'll enter the data separately for their different treatments, right? So in this case, I've divided up my control group here, and I've got their outcomes, their lengths and their weights, and then I've got the data for the experimental group here. Now I get how this, why someone might do this, but this does not work when it comes to analyzing the data, because if you're analyzing, for instance, length, you're analyzing length for everyone. So the stats program will not easily recognize that this control length and this experimental length are actually the same thing, and you want to compare them between this group and that group. So what works for using a stats program is that you have all of a given variable in the same column, right? So length is length, whether I'm measuring it in a control bug or a experimental bug, and you have it all in one column, and then the stats program can easily tell which of the observations are control bugs and which are experimental bugs.